For years, lithium-ion batteries have quietly powered almost everything around us. Phones, electric cars, laptops, energy storage systems. Even massive renewable energy projects now depend heavily on them. Most people assumed lithium-ion batteries would dominate for decades because right now they are everywhere. But behind the scenes, some of the world's biggest companies are already racing towards something else entirely, and the reason is simple. Lithium-ion batteries may be reaching some very real limits that are becoming harder to ignore as technology scales up. The problem is not that lithium-ion batteries are useless. In fact, they helped make the modern electric vehicle industry possible. They helped renewable energy storage become commercially viable, and they transformed portable electronics forever. But as energy demand explodes from AI infrastructure, electric vehicles, and massive battery storage projects, companies are starting to ask whether the current technology is truly good enough for the future they are trying to build. That is why a global battery race is now accelerating, and some people believe the next breakthrough could completely reshape the future of clean energy and transportation. Lithium-ion batteries became dominant because they solved several major problems at the same time. Compared to older battery technologies, they offered much higher energy density, meaning they could store more power in smaller and lighter packages. That made them ideal for portable electronics first, and eventually electric vehicles as well. At the same time, manufacturing improved rapidly. Costs began falling. Supply chains expanded, and massive companies started investing billions into lithium battery production because demand kept rising every year. Eventually, lithium-ion batteries became the backbone of the modern battery economy. Today, they power everything from smartphones to grid-scale renewable energy storage facilities. But success created a different problem. The more the world relies on lithium-ion batteries, the more pressure builds around cost, raw materials, charging speed, safety, lifespan, and energy density. And that is exactly why companies are now searching for alternatives. One of the biggest limitations of lithium-ion batteries is that improving them further is becoming increasingly difficult. Battery technology does not improve as dramatically as computer chips. Each improvement usually takes years of research, manufacturing redesigns, safety testing, and enormous investment. At the same time, demand is exploding faster than many experts expected. Electric vehicle adoption is increasing globally. AI data centers are consuming massive amounts of electricity. Renewable energy systems need larger storage solutions to stabilize power generation. And governments are pushing for cleaner transportation and industrial systems. All of this creates huge pressure on battery technology. The world does not just need more batteries anymore. It needs batteries that are cheaper, safer, faster to charge, longer lasting, and easier to scale. That is where next-generation battery technologies enter the conversation. Right now, solid-state batteries are probably the most talked-about challenger to lithium-ion technology. The reason is simple. In theory, solid-state batteries could offer higher energy density, improved safety, and faster charging compared to many traditional lithium-ion designs. Instead of relying on liquid electrolytes like conventional lithium-ion batteries, solid-state designs use solid electrolytes. That may reduce some fire risks while also potentially improving battery performance. This is why companies like Toyota and QuantumScape have invested heavily in the technology. Toyota has repeatedly hinted at major solid-state battery ambitions because the company sees next-generation batteries as potentially critical for the future of electric vehicles. QuantumScape, which gained major attention through its partnership with Volkswagen, has also positioned itself as one of the companies trying to commercialize solid-state battery technology at scale. The excitement around solid-state batteries is enormous because if companies can solve the manufacturing and scalability challenges, the technology could significantly improve electric vehicles and energy storage systems. But there is an important catch. Solid-state batteries are still difficult and expensive to mass produce at scale, which means the technology is promising but not yet fully dominant. A lot of people talk about solid-state batteries as if they are the only possible successor to lithium-ion technology, but that is not actually true. Several other battery technologies are now receiving serious attention as companies search for different solutions to different problems. One of the fastest-growing alternatives right now is sodium-ion batteries. The reason sodium-ion batteries matter is because sodium is much more abundant and potentially cheaper than lithium. that could help reduce some supply chain pressure and lower battery costs in certain applications. Companies like CATL have already started pushing sodium-ion development because they see potential advantages for affordability and large-scale energy storage. But sodium-ion batteries are not perfect either. They currently struggle with lower energy density compared to many lithium-ion batteries, which can make them less attractive for some long-range electric vehicle applications. At the same time, researchers are also exploring lithium-sulfur batteries, silicon-anode batteries, metal air batteries, graphene-based battery, and even newer experimental chemistries that could dramatically change energy storage over the next decade. Silicon-anode batteries are emerging as a major upgrade to today's lithium-ion technology by replacing the traditional graphite anode with silicon, which can store far more lithium ions and therefore significantly increase energy density. However, the challenge has been durability, since silicon expands and contracts heavily during charging, causing degradation over time, though new engineering approaches are steadily improving stability. Lithium-sulfur batteries are another promising direction, offering the potential for much lighter and cheaper energy storage because sulfur is abundant and low cost, but they still face issues with short lifespan and energy loss during cycling. Alongside these, graphene-based battery research is exploring how this ultra-thin, highly conductive material can improve charge speed, efficiency, and thermal performance, although it is still largely in experimental or early commercial stages compared to the others. Some of these technologies focus on higher energy density. Others focus on lower cost, safety, charging speed, or sustainability. This means the future battery market may not be dominated by one single technology alone. Different battery types could end up serving different industries depending on what problems they solve best. Most people associate battery innovation mainly with electric vehicles, but the implications are much bigger than that. The future of renewable energy increasingly depends on energy storage. Solar and wind power are growing rapidly around the world, but renewable systems become much more powerful when excess energy can be stored efficiently and used later when needed. That means better batteries could directly affect how fast renewable infrastructure scales globally. At the same time, AI infrastructure is creating another massive energy challenge. Modern data centers require enormous amounts of electricity, and many companies are now looking at battery storage as part of broader energy management strategies. This means the battery race is no longer just about transportation. It is becoming connected to renewable infrastructure, industrial competitiveness, grid stability, and future digital infrastructure as well. Countries and companies that lead in battery technology could gain major economic and strategic advantages in the coming years. Right now, lithium-ion batteries still dominate the market. That is important to understand. This is not a story about lithium-ion disappearing tomorrow. The infrastructure around lithium-ion batteries is already enormous, and companies have invested hundreds of billions of dollars into scaling the technology globally. But history shows that dominant technologies do not always stay dominant forever, especially when demand changes faster than the technology itself can evolve. That is why companies are now racing to find the next breakthrough before someone else does. Because whoever leads the next battery revolution may end up shaping the future of transportation, renewable energy, AI infrastructure, and industrial technology all at the same time. For years, lithium-ion batteries helped power the rise of modern technology. Now the world is asking whether something even better is coming next. Solid-state batteries are attracting massive attention. Sodium-ion batteries are rising quickly, and several other experimental technologies are quietly advancing in the background. Some of them may fail. Some may take much longer than expected. But one thing is becoming increasingly clear. The global battery race is no longer just about improving phones or electric cars. It is becoming a competition to power the future itself.